geometry lesson on conditions for rectangles, rhombi, and squares. And this is a continuation from 9.3. And there we studied the properties of rectangles, rhombi, and squares. And very similar to the parallelogram, we are trying to prove that the converse of the properties are true, right? And converse becomes the condition for which a uh, quadrilateral is either rectangle, rhombus, or a square. Okay, guys? All right, the first of which is you should copy this down, all the underlined stuff. The very first ones we're going to be dealing with is the proving that the congruent diagonals is a condition for a rectangle, right? So we've done the proof of this before. We just are going to do this in reverse, right? All right. So if one angle of the parallelogram is a right angle, then the parallelogram is a rectangle. Hmm. I think we did that already, right? All right. Hmm. So I think the idea was that if you have a rectangle over here, guys. So this textbook, instead of making a definition, made into a theorem, and this is parallel like this, right? The idea is that then opposite sides are congruent, and because this angle can be considered, these two are parallel. A same side interior angles has to be supplementary, which means that this is also 90 degrees, and that was the idea that I just shared with you guys, right? For this one, if the diagonals of the parallelograms are congruent, then the parallelogram is a rectangle, right? And that's the proof that we're going to be doing, guys. Okay. Understand that because this particular theorem came in after this one, you could use any theorem that came before this, right, as a theorem. Okay. Why don't you pause the video and start working on this particular one, guys? Okay. You could do either as a two-column proof or as a paragraph proof. I think I'll be showing this to you as a paragraph proof. Okay, here we go. Stop the video and work on the problem, please. All right, guys, enough of that. Here we go. And this is the way I did it. Okay. First of all, we know that this is a parallelogram, and we know that the AC and BC are congruent. And we could separate these two triangles, guys, apart, and we have ADC and we got BCD. And we know that DC is congruent to DC because of what? Exactly. It's reflexive. And we'll say all that again, but I like to walk through the problem before I actually write it out. And we know that this and this is congruent because the opposite sides of the parallelograms are congruent. And we know they're parallel at the same time, right? And what else is the same? Oh, yeah, by the way, we also know that the um, we're given that diagonals of the parallelograms are congruent, so we know that the AC and BD are also congruent. Hold on a second. If that's the case, is this like congruent by side, side, side? Yes. In fact, that's exactly what I said. Uh, this is the given information. ABCD is a parallelogram, and AC and BD are congruent. And that's basically what I said over there, guys, right? Then we know that the triangle ADC is congruent to triangle BCD by side, side, side congruent triangle theorem or triangle congruence theorem. So we know that the D and C are congruent by CPCTC, this two, right? These two are congruent. And we know that the AD and BC are parallel by definition. And we know because of that, and D and C are also supplementary by cointer theorem. So if they are 180 degrees, sums of them are 180 degrees, right? And they're congruent to each other. So I can replace D for C because if they're congruent, then their measures are exactly the same, right? So doing some algebra, we know that angle C is 90 degrees and C is at 90 degrees, right? If C is right angle, then it's 90 degrees. And we know that from the previous sentence, theorem that ABC must be parallelogram is a rectangle because uh, sorry, it has to be rectangle because parallelogram with one right angle is a rectangle, right? So that's why it's convenient to have that particular theorem in a different book. That was actually the definition, because it's really time consuming to go through the same thing to show that the rest of them has to be a right angle. It could be done, but this saves a lot of time. And sometimes different theorems are made so that we could actually go through that. So that to the next theorem becomes easier. Okay. All right, guys. Moving on. So here is conditions for showing that a quadrilateral is a rhombus. Right. The first thing that we're going to do is if one pair of the consecutive sides of parallelogram are congruent, then it must be rhombus. If you think about that, that actually makes sense because let us say that we know that if it's a parallelogram, right, opposite sides are congruent. If the consecutive sides are congruent, then this is equal to this, which becomes the opposite sides of the same. So therefore, all four sides are the same. By the definition, it must be rhombus. So you should be able to write that out if I ask you to. Okay. And then the other condition is that if the diagonals of the parallelogram are perpendicular, then there must be rhombus. How's that so, guys? Well, because it's a parallelogram, right? We know that the opposite sides are congruent, like this, right? If this is right angle, you know that by vertical angle, this must be right angle. True. Okay. And by definition, by one of the properties of the uh, parallelogram, the diagonals bisect each other. So this and this is the same. This and this is the same. So that tells us that this particular triangles are congruent by side, 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 or side angle side, or whatever, right? Or you could just state one of them and call it HL, hypotenuse leg. Anyways, these two are congruent, right? So what does that tell you, right? And then the diagonals of the parallelogram are perpendicular, right? So if that's the case, uh, then this triangle is the same, this triangle is the same, and we can make the same argument that that is the case right here, guys. And we can make an argument that these two triangles, but that doesn't seem to do anything. But here's the thing, though. We know that these two are the same. That's reflexive. That's 90. So by side angle side, these two triangles are congruent. Do you see that, guys? Yes. Then by CPCTC, that these two sides are congruent. Very good. Then we could use this particular theorem to show that this here must be congruent. Okay. Now, I apologize for taking you through different thought processes, but that's what you need to do to be able to prove that something is congruent. It's not always neat like we present it to you guys. And the third one that we're learning is that if one diagonal of the parallelogram bisects a pair of the opposite angles, then how would you do that? So we got a parallelogram that's given to us, and if a diagonal bisect, so what that means is that this wasn't okay. So this and this is the same, and this is the same. Okay. Then how would you do that? Do me a huge favor, guys. Why don't you guys go ahead and start the proof? And as you know, this is the last statement that you should have. Okay. Why don't you go ahead and take a little bit of time, stop the video, and work on the problem, guys. All right, guys. Here we go. And this is what I did. The first thing I did is I said that the AC must be congruent to itself. If you do that, you could clearly see that the angle ABC and ADC are congruent because of the angle side angle, right? Triangle congruence theorem. So we know that the AB and AD are congruent, and BC and CD are congruent. Now, what you could have done is just, I could have done one step, but let us say that we didn't know the first theorem that was given to us. Then you will have to continue to go on and say that the BC and AB are congruent, right? And we know that the AB is congruent to AD, right? I just wrote that out, and I wrote that out, but this connects it. So because of transitive property, right, all four sides are congruent. So ABCD is rhombus. However, that is if you didn't know the first step, okay? Instead, what you could have done, right, is this, right? 6. The way that I expected you guys to do this was that the ABCD is rhombus, oopsie, because of the first theorem, which says that if one pair of consecutive sides of parallelogram are congruent, then the parallelogram is rhombus. Okay, so you could have said that instead. Okay, so this is completely up to you which way you do it. So I'm just showing you the alternatives. Okay, all right, guys. Why don't you guys go ahead and try this? Pause the video and play this when you're ready. Okay, you guys ready? All right, here we go. So we have we need to determine if the given conclusion is valid. So here's the given information, guys, for the A. We know that the AB and CD are congruent, and the BC and DA are congruent. And AD and DC are perpendicular, and AC and BD are perpendicular. Is this a square? Well, answer was yes, right? Well, here it is. We know that by doing this, ABCD is parallelogram because opposite sides are congruent, right? And ABCD is a rectangle because D right here is a right angle. So we know that this is a rectangle, right? And we also know that it's rhombus because diagonals are perpendicular, right? Right. So so parallelogram that has diagonals that are perpendicular is called rhombus, right? And therefore ABCD is a square because it is both a rectangle and a rhombus. That's the reason why I offered you that alternate definition, and it's much more convenient to do so, right? And the second one was AB and BC are congruent. Yeah, that doesn't tell me anything. So it's possible for us to be congruent, and the rest looks like this, right? Can I draw something else given the information? And answer is yes, right? Um, I think this would have been okay if the additional information was what? If they give us that ABCD's parallelogram, but it didn't. So that was it. Okay. All right, guys. So this is your turn. We got 2 questions over here, guys. Okay. Let me see if you could do this on your own. Stop the video, work on the problems, guys. All right, so I'm going to assume that you finished it. So here are the answers. For number 6, that is it. And for number 8, that is a question. All right, so if you have a question on this, we'll talk about it in class. So I will see you in the next video. Okay, have a good night.